Good afternoon. My name is Archana Arvind. Here I am going to take a class on objects and classes in C++. BCA Ignou classes. Third semester. This is encapsulation. Encapsulation is one of the object-oriented programming methods. OOPS concepts. One of the OOPS concepts is encapsulation. In this section, we will discuss about encapsulation. Encapsulation is one of the important characteristics of object-oriented programming language. As we have discussed, a class can be described as a collection of data members and member function. That means a class can be described as a collection of data members and member functions. This property of C++, which allow wrapping up of data and functions into a single unit, is called encapsulation. This property of C++ of wrapping up of data and functions into a single unit is called encapsulation. Data encapsulation is most striking feature of a class. Could you tell what are the concepts of encapsulation? Well, the advantages of encapsulation are data hiding, information hiding, and implementation independence. Let us see what these terms mean. If the implementation details are not known to the user, it is called information hiding. Restrictions of external access to features of a class result in data hiding. The user's interface is not affected by the changing the implementation mechanism. A change in the implementation is done easily without affecting the interface. This leads to implementation independence. Accessibility rules or labels. You can see in the class declaration, we have used three terms: private, public, and protected. Can you tell what is the purpose of these terms in the program? Right. Private, public, and protected are known as visibility labels, used to control the access to members, data members, and members function. What are public, private, and protected? They are known as visibility labels. Public, private, and protected are known as visibility labels, used to control the access to members, data members, and member functions of a class. Why do we need to control the access of members of a class? Well, as we know that the purpose of data encapsulation is to prevent accidental modification of information of a class. Data can be protected from external tampering by users, and access to specific methods also can be controlled. However, an entire program cannot be hidden. A part of the program needs to be accessed by users. For this many other reasons, we need to access the members of a class in controlled way. It is achieved by imposing a set of rules in the manner in which a class to be manipulated and data and functions of the class can be accessed. The set of rules is also known as accessibility rules. These accessibility rules are achieved by using three keywords: private, public, and protected. These keywords are called access control specifiers. Then, the another important question: what are access control specifiers? Private, public, and protected keywords are also called access control specifiers. Visibility mode. The visibility of class members is summarized in table. On class members, objects of classes. Protected access control specifiers: private, protected, public. From the above table, you can observe that the private and public protected members of a class are accessible only from within other members of the same class. They are not accessible by the objects of a class. Further, public members are accessible both from members of the same class and objects of a class. They are accessible from anywhere where the object is visible. Members of a class without any class specifier, access specifier, are private by default. A class which is totally private is hidden from the external world and will not serve any useful purpose. Can you access a private member of a class from outside the class? Yes, we can have a mechanism to access private data using friends, pointers to members, etc. from outside the class. A class can use all of these three visibility accessibility labels as illustrated below. Public class A. opening bracket, private, opening brackets, curly brackets, private, int x, void function 1. This function can refer to data members x, y, z, function 1, function 2, function 3. Protected, int y, void function 2. This function also refers to data members x, y, z, function 1, function 2, function 3. Public, int is that, void function 3. An object may have a name, a set of attributes, and a set of actions or services. This function can also refer to data members x, y, z, and function 2, function 3. Now consider the statements. Accessing private members of the class A. The above statements define an object and integer variable b. Accessing private members of the class A. B equal to obj dot x won't work. The object cannot access private data number x. Obj function 1 won't work. Object cannot access private member function 1. Both the statements are legal because the private members of the class are not accessible. Accessing protected members of the class A. B equal to obj A dot y won't work. Object cannot access the protected member y. Obj function 2 won't work. Object cannot access member of function 2. Both the statements are also legal because the protected members of the class are not accessible. Accessing public members of the class A. B equal to object obj A dot c. Okay, obj function 3. Okay. Both the statements are valid because the public members of the class are accessible. Objects. In this function, we will study about object. What is object? What is the relation between object and class? How will we create object? We shall make an attempt to such address this question. In Webster's New World Dictionary defines object as a thing that can be seen or touched, material thing, a person or thing to which action, thought or feeling is directed. Or we can say an object is a real world entity. Real world entity. An object is a real world entity. Examples for object: computer, book, desk, bench, etc. Example for object. Oh. In object-oriented domain, an object is one of the main things that together constitute the problem domain. We can look around and find many real-world examples of objects like person, customer, student, employee, car, dog, table, bike, etc. An object may stand alone or it may belong to a class of similar objects. Examples of objects that may stand alone are knife, frame, etc. Examples of objects that belong to a class of similar objects are your car, your table, etc. Can you tell the difference between objects and class? Well, objects are the basic runtime entities in object-oriented programming language. They occupy space the memory that keeps the state and is operated by the defined operations on the object, while a class defines a possible set of objects. What is the relationship between object and a class? The relationship between object and a class of that class is similar to the relationship between a type of elements of that type. A class represents a set of objects that share a common structure and common behavior, whereas an object is an instance of a class. In the next section, we will see how object is created. Instantiating object. The declaration of a class does not define any object, but only specify the structure of objects, what they will contain. A class must be instantiated in order to make use of the services provided by it. This process of creating objects, variables of class, is called class instantiation or instantiating object. Thus, an object is an instantiation of a class. The common syntax of instantiating object of a class, declaration of an object, is as follows. Class, public class, class name, object 2, object, or class name, object name 1, object name 2. For example, let us see how we will create the object of the employee class discussed in the exercise. Public class, employee 1 or employee 1. You can see the public class name. You can see that the declaration of object is similar to that of a basic type. You can also notice that the keyword class optional. Employee class created object employee 1. More than one object can also be created with a single statement as follows: employee 1, employee 2, employee 3. Objects can also be created by placing their names immediately After the closing brace, as we do in the case of thus, the definition class employee 1, employee 2, employee 3 would create objects employee 1, employee 2, employee 3 of the class employee. Now let us see how we will access the members of a class. We can access the members of a class using the member access operator. Member access operator dot. We can access the member of a class using the member access operator. How we can access member class members access dot uses member access operator adava dot. The syntax for accessing data member of a class is given as follows: object name dot data member. The syntax for accessing member functions of a class is given as object name dot function name actual argument. Object name dot function name dot actual arguments. Let us consider the snapshot of a program which illustrates the use of dot operator. Public class ABC. Opening the curly bracket, index into I void float void public int z void f2 f1 void public int z void f2 void main return 0 abc equal to a ax equal to 10 az equal to 10. Okay, z is public data. A f1 error, f1 is private function, a f2. Okay, f2 is a public function. If you look at the above snapshot of the C++ program, you can observe that private data like x and private number function, a member function like f1 cannot be accessed to object, while public data z and public member function f2 can be accessed to the object. Furthermore, this program shows that you can access the members of a class through dot operator, member access specifier. Okay. Let us consider the complete program of employee.cpp, which illustrates the declaration of the class employee with the operation on this object. Further, it is also seen that how we will access the members of a class. This program reads the basic information of employee like ID, name, age, etc. from the keyboard and display on the screen. Comments. Comments are the non-executable part of a program. Comments program colon employee.cpp. Hash include iostream.h, hash include string.h, public class employee. Opening the bracket, int id, int age, car name 25, public int salary, void get underscore data, void cout, insertion operator enter id, end 1, see insertion id, cout, insertion operator enter name, end line, see insertion operator, see in extraction operator name, cout, insertion operator enter age, end line, see in extraction operator age, cout, insertion operator enter salary, colon, double quotes, insertion operator end line, see in extraction operator salary, void display underscore info void, opening the curly bracket, cout, insertion operator, new line and new id, insertion operator id, end line, cout, name end line, cout age end line, cout salary end line, void main, employee 1, first object variable of employee class, employee 2, second object variable of employee class, cout enter employee basic information in line event dot get data, object event calls member get data, cout enter the second employee basic information in line e2 get data, with e2 calls member cout n1 employee basic information in line, object event member information data basic information, object e2 calls member information. The output of the above program is given below. Enter first employee information, enter id 100, enter name AK Malvia, enter age 39, enter salary 20,000, enter second employee basic information, enter id 101, enter name and Badal, enter age 35, enter salary 20,000, first employee basic information ID 100, name AK Malavia, age 39, second salary 20,000, second employee basic information ID 101 in Badal, age 35, has salary 20,000. This program shows how we can access members of a class with the help of a object. Furthermore, it also illustrates that the various operation on the objects of the class employee in the main statements employee 1, employee 2 create two objects called E1 and E2 of the employee class. Statements E1 dot get underscore data, E2 get data, initialize data members of objects E1 and E2. The statements E1 display information, E2 display information, call their display information to display the contents of data members, namely ID, name, age, and salary of the employee objects E1 and E2. Member functions. In this function, we will discuss what is member function, how we will define a member function. A member function performs an operation required by the class. It is the actual interface of the initiate an action of an object belonging to a class. It may be used to read, manipulate, or display the data member. The data member of a class must be declared within the body of the class, while the member functions of a class can be defined inside the class definition, outside the class definition. The syntax of a member function definition changes depending on whether it is defined inside or outside the class declaration definition. However, irrespective of the location of the definition, the member function must perform the same operation. Thus, the code inside the function body would be identical in both the cases. The compiler treats these two definitions in a different manner. Let us see how we can define the member function inside the class definition. The syntax for specifying a member function declaration is similar to a normal function definition except that is closed within the body of a class. For example, we could define the class as follows. Public class number index y is that public void get underscore data void declaration void maximum void semicolon declaration void minimum void definition int minimum equal to x if minimum greater than y minimum equal to y if minimum greater than x minimum equal to c out insertion operator minimum value is minimum end line curly bracket closing. If you look at the above declaration of a class number, you can observe that a member function get underscore data and maximum are declared, but they are not defined. The only member function which is defined in the class body is the minimum. When a function is defined inside a class, it is treated as an inline function. Thus, member function minimum is a inline function. Generally, only small functions are defined inside the class. Member functions that are declared inside a class they are defined outside the class. Their definition is very much like the formal function. Can you tell how does a compiler know to which class outside a defined function belong? Yes, there should be mechanism of binding the functions to a class to which they belong. This is done by the scope resolution operator. Yes, there should be a mechanism of binding the functions to a class to which they. This is done by the scope resolution operator. Scope resolution operator acts as an identity label. This label tells the compiler which class the function belongs to. The common syntax of the member function definition outside the class is as follows. Return underscore type class underscore name scope resolution operator function underscore name argument declaration opening bracket function body. The scope resolution operator tells the compiler that the function underscore name belongs to a class underscore name. Let us again consider the class number. Opening bracket open index y z public void get core data declaration void maximum void declaration void number get underscore data void see out insertion operator enter the value of first number in line see insertion extraction operators see out insertion operator enter the value of second numbers in line see insertion extraction operator see in extraction operator y see out insertion operator enter the value of third number is said extraction operator in line see in insertion operator in line see in extraction operator is said void number the console operator whether it is the scope of the function name then type the scope resolution operator. Okay, the scope resolution in the above example void number the scope resolution operator get underscore data void see out enter the value of first number in line see in extraction operator x see out insertion operator enter the value of second number Insertion operator in line, C in, extraction operator Y, C out, extraction operator, insertion operator, enter the value of third number, Z, insertion operator in line, C in, extraction operator Z, void number, scope resolution operator, maximum void, into maximum equal to X, if max less than Y, max equal to Y, if max less than Z, max equal to Z, C out, maximum value, max and line. If you look at the above declaration of class number, you can easily see that the member function get underscore data and maximum are declared in the class. Thus, it is necessary that you have definition this class. You can observe in the above snapshot of C++ program the entity level which are used in the void number, scope resolution operator, get underscore data, void, and void number scope resolution operator, maximum void tell the compiler the function get underscore data and maximum belong to a class number. Now let us complete the C++ program to find out the minimum and max of three given integer numbers. Hash include iostream.h class, public class number. Open the curly bracket, index wise the public, void get data, void declaration, void maximum, void declaration, void minimum, void definition. In the minimum equal to 6, if minimum greater than y, minimum equal to y, if minimum greater than z, minimum equal to z. C out, insertion operator, minimum value is minimum in line, closing the curly brackets, void number scope resolution operator, get underscore data, void. C out, enter the value of first member X, insertion operator in line, C in, extraction operator X, C out, insertion operator, enter the value of second number, enter the end line, C in, Y, C in, extraction operator Y, C out, extraction operator, enter the value of third number and line, C insertion operator, C in, extraction operator Z, closing the bracket, void number, scope resolution operator, maximum void, into max equal to X, maximum equal to X, if maximum less than Y, maximum equal to Y, if maximum less than X, maximum equal to Z. C out, insertion operator, maximum value is, insertion operator, maximum insertion operator, end line, void main, open the curly bracket, number, get underscore data, minimum, dot, number, dot minimum function, number, dot maximum function, closing the bracket. The output of the above function is given as below. Enter the value of first number X, 10. Enter the value of second number Y, 20. Enter the value of third number Z. Minimum value is 5. Maximum value is 20. Thank you. That's all for today's session.